All right, hey guys, today we're going to go over factoring trinomials. Yesterday you did some whiteboard work with your group where you came up with how to factor trinomials using grouping. So today we're just going to kind of formalize it, and you might want to take a couple notes in your notebook as we do this. So you guys should know a trinomial looks like this. So today we are going to work on factoring these by grouping. So let's start with what we learned yesterday. So if we want to factor something like this, we did a couple things, and we learned that if you multiply these two, I'm going to put that on the top, that I want to find two numbers that if you times, they equal 12x squared, but when you add, you need 8x's in the middle. So that's basically what you came up with when you did all that whiteboard work. So I need to figure out, well, what times what is 12, but when I add, I get 8. Well, that would be a 6x and a 2x, because 6x times 2x is 12, but when you add, you get 8. So now we're just going to split this up and rewrite it as x squared plus 6x plus 2x plus 12. Now we can factor by grouping, which is what we did in the lesson before yesterday. So now I'm going to just group the first two and see if they have a common factor. Well, I can rewrite that. They have a common factor of x. So I'm going to rewrite it with the distributive property as x times x plus 6. And in the back, I'm going to group this, and they have a common factor of 2. So I'm going to rewrite that as 2 times x plus 6. All right, then our last step is just to rewrite this. They have a common factor of x plus 6, so I can say this is the same as saying x plus 6 times x plus 2, and we get that from right there. And then the last thing that we did was just double check that this is correct. So I'm going to do x times x is x squared, x times 2 is 2x, 6 times x is 6x, and 6 times 2 is 12. If I combine like terms, I end up with x squared plus 8x plus 12, which is what my original problem was. So you just factored this trinomial up here. Your final solution is this. And again, I talked to you guys about what factoring means, but if you take those two things and multiply them, you would end up with this. So these are equivalent to each other. All right, let's try another one. So again, I'm going to draw my little X, or these are really called diamond problems. And we know that we want two numbers that when we add, we get negative 7x. We want to kind of split that. And then we learned that, hey, if you take these two terms and you multiply them, so 6x squared minus 3, that's negative 18x squared. Okay, so we want to come up with two numbers that equal that. So what times what is negative 18? But when you add, you get 7. That would be a negative 9x and a positive 2x. So now I'm going to split this up into negative 9x plus 2x. So that still equals negative 7x. And then I still have 6x squared and minus 3 at the end. All right, so now we're going to factor by grouping. So I'm going to group these first two terms and see a common factor they have. It looks like they both have a 3x. So I'm going to rewrite this with the distributive property. That would be 2x and minus 3. Again, if you times this out, you should end up with what you had up there. And then in the back, nothing goes into 2 and 3, so I'm just going to write it with a 1 out front, because this still equals the same thing. And now I'm going to notice that, hey, they both have this shared factor here. So I'm going to say that's the same as doing 2x minus 3 times 3x plus 1. Okay, so now, again, I just want to show you where this number came from when we did it yesterday. So yesterday you guys kind of explored, and we wrote it like this: 2x minus 3 and 3x plus 1. We get 6x squared minus 9x, 2x, and negative 3. So if you remember from yesterday, you guys came up with this. We said, hey, the diagonals, so if I had like 2x and negative 9x, they had to equal their negative 18x squared. Same thing here. Those two diagonals equaled negative 18x squared. So that's how we come up with this diamond problem on the top, or this like x problem, because we realized that, hey, the two numbers I'm looking for to split this negative 7x into, when I add them, they have to equal negative 7x, and then when I times them, they equal negative 18x squared, and we got this from that pattern we found yesterday. All right, let's try another one. So This time, again, let's do our little diamond problem. When I add, I want 9x, and when I multiply, this is really like a 1, it should be 14x squared. So you have to think of, well, what times what is 14, but when you add, you get 9. Well, that looks like 7x and 2x. Okay, so then I'm going to rewrite the 9x as x squared plus 7x plus 2x and then plus 14. All right, then I'm going to factor by grouping. Okay, so I'm going to group a couple terms together. I'm going to say, hey, x goes into both of those. That'd be x plus 7, if I rewrote that. And 2 goes into both of these, which is x plus 7. And then finally, they both share that x plus 7. So it's x plus 7 times x plus 2. And if you times that out, it will give you the original trinomial. All right, I would like you to pause the video and try this one. After a couple minutes of trying it, you can push play. Okay, so let's draw our thing out because we need to split this 3x up. So I know when I add, I want it to equal 3x. And then when I multiply, 2 times 5 is 10x squared. I want it to be 10x squared. So you have to think of what times what is 10, but when you add, you get 3. Okay, if you're getting stuck, start listing the factors of 10. Well, I know it's 1 times 10, 2 times 5, nothing else goes in there. Okay, so then I think of, well, can I make a 3 out of either of those? Well, definitely not out of 1 and 10. How about 2 and 5? Well, I could make a 3 if this was negative, but negative 2 times 5 is not 10, so that doesn't work. Okay, so if you cannot factor it, sometimes you cannot factor something, we call that prime. So if it's not factorable, you can write it as prime. You can also write it's not factorable, but just know that these two words mean the same, okay? So if a polynomial cannot be factored using integers, so that basically means using like whole numbers that are positive or negative, if it can't be written like that, then you can write prime. It still might be able to be factored with like a decimal or something like that, something not so nice. But if it can't be factored using integers, you can write the word prime. Okay, when you're on your homework, don't just write prime. You actually need to try them. So when you're doing it, so if I was doing this one, I'd put 24x squared, 5x. Okay, if you're stuck, start listing what goes into 24. I'll write 1 times 24, 2 times 12, 3 times 8, 4 times 6. Then I try to make a 5 out of that. So don't just write prime. I should see you trying some of the different factors. All right, let's try this next one. All right, so this next one is a little bit special. So before you try to factor a trinomial, first thing you should do before you do anything is to see, is there something I can divide out of all of those 3 numbers? I see 2 goes into all of these, so I'm going to rewrite this with the distributive property as 2 times 2x squared plus 9x minus 5. Now, I'm still going to keep my 2, but I basically want to figure out 2 times something gives me this 4x squared plus 18x minus 10. So now I'm only really going to use this trinomial on the inside, but I'm going to keep the 2 over there. So I'm going to think to myself, I'm going to draw my little diamond problem. Okay, I need it to add to 9x. Okay, and then it needs to multiply to 2 times negative 5 is negative 10x squared. So think to yourself, what times what is negative 10? But when you add, you get 9. Well, I think I can make a 9 out of a 10 and a 1. Okay. This one needs to be positive. This would be negative 1x. So now I'm going to come down here and I'm going to rewrite the 2x squared plus 9x minus 5. I'm going to rewrite that as 2x squared plus 10x minus 1x minus 5. All right, now I can factor it by grouping. Okay, so I'm going to group those 2 together, group those 2 together. So I'm going to divide a 2x out of the first one, which would give me x plus 5. And in the back, I'm going to divide a negative 1 out of both of those. So negative 1 would leave me with x plus 5. Remember, your goal is to get that same thing on the inside of both of them. So now it shares that factor. So now I end up with x plus 5 times 2x minus 1. Now, that's not my final answer. I had divided a 2 out to start with, so I'd still have to times this whole thing by 2. Okay, so my final answer would be this. So if I do this again, I'll come write it up here. It's 2 times x plus 5 times 2x minus 1. If I just multiplied these two things out here in green, I would end up getting back to the 9, the 2x squared plus 9x minus 5. Then if I times it by 2, it would get me back to the original problem. All right, why don't you guys pause the video and try this one? All right, first thing, you guys can divide a 3 out of here. It looks like 3 goes into all of them. So I'm going to rewrite it as 3x squared plus 10x plus 9. Again, this still says the same thing. I just rewrote it using the distributive property. Now I'm going to do my little diamond problem and just work on this part. So when I add my x's, I need it to be 10x. And when I multiply, remember you do 1 times 9 here. I need it to be 9x squared. So what times what is 9, but when I add, I get 10. Well, I think if I just did 9x and 1x, that would get me to 10x. So now I'm going to split this up. It's x squared plus 9x plus 1x plus 9. All right, let's factor it by grouping. So I'm going to group these two things. So it looks like the greatest common factor there is an x. So it's going to be x plus 9. And in the back, that grouping, it looks like the greatest common factor, these should have been brackets, I apologize, those are brackets, is plus, I'll divide a 1 out, it's still x plus 9. Your last step then is to rewrite it one more time. They share that common factor of x plus 9 and then times x plus 1. Now, this is the part a lot of people forget. Don't forget that you had a 3 is another factor of that. So I need to bring the 3 back to the front. There is your final answer. So you factored this trinomial. Okay, if I multiplied this out, it would equal that original trinomial. So these are factors of that trinomial. So our learning goal for today is that I can factor a trinomial and do that by grouping. So hopefully you feel okay about factoring trinomials. Now you're going to do some practice. There is a worksheet that the sub will have for you, so you're going to try that. You can check your answers in Schoology. If you finish that, I have some other things posted in Schoology, so just make sure you check Schoology for all of your directions.